I'm going to explain this DS1307 RTC clock. We're going to have a look at the datasheet. Then I'm going to build a simple project to display the time on the serial monitor. After that, we are going to test the alarm feature so we can turn on and off a light using a relay. And also we're going to build LCD display clock and with 2004. Also we are going to build LED 7 segment clock, and finally we will have unlimited alarm project so you can control multiple devices with this module. The unlimited alarm with the LCD off using this push button. Hi, welcome to an Arduino step-by-step course by Robojax. The larger screen, click on this area of the player so you can see all the chapters. On your mobile device you will see the menu. When you touch it, you see all the chapters, and then click and touch to move to that section of the video. This is the real-time clock module where you can have a full calendar. It has a battery that is holding the power. When the Arduino doesn't have any power or this is disconnected, it will run and keep going and will keep the track of time, but it needs setting the current time, so you will set it only once and it will keep it. It has this 32,768 Hz crystal oscillator which will oscillate, and if you divide this 16 times you will get 1 Hertz. So that's why we are getting 1 Hertz, and based on that the rest of the calculation from the second we go to the minute, hours, day, month and year will be calculated. And we can use it only with just 4 wires, 5 volts. I tested it with 3.3 volts also, it worked. So with 5 volts and then I2C or I2C communication, just 2 wires to read the data from this. On this side we have ground and VCC. This is for 5 volts, SDA and SCL. These are for communication and reading and writing the data to this chip. And then we have DS, which is for reading the temperature if we install that chip here. And the same pins are here, but we have battery at the end where you can read the voltage for this battery from this pin if you need it. And also the rest is the same except we have DS at this point, and then we have SQ. This is a square wave pin from the chip, and we can select different frequency and read it here for some application if you need it. The module might be sold without battery or with a battery. Uses CR2032 3 volts lithium battery. Get the rechargeable battery, so the battery every time you connect it to power will be charged. And here is a chip, the temperature sensor that is used for this spot, and we can read the temperature from this pin or DS at this spot. The module is 27.4 millimeters by 28.6 millimeters. With the battery and the oscillator, it is 9.9 millimeters, 10 millimeters. And if you want to know the weight, with the battery, 7.4 grams. Without the battery, 3.8 grams. And here is the schematic. This is the chip, the real-time clock DS1307. We have the pin that is connected to the VCC, the pin that is connected to the battery. This is a battery that receives the voltage, and from VCC this diode allows this to be charged. When the VCC is not connected, this is blocking the current to go to that direction. And then these two pin X1 and X2 is connected to this 32,768 Hertz crystal oscillator. And then we have SDA and SCL pin which are connected to this pin header, pin 4 and 5, and then we have small header. We have this header, and then we have this long header. So SDA and SCL is also in the P2 and on P1. Ground is connected to the ground, so we have one ground. And as you can see, there is no other pin. And then we have a square wave out, SQ. Here it's labeled as SQ, which is connected to the pin header number 2, SQ. That's the clock output from this, so you can get it if you need it for some other application. And then the last pin is here DS. Also on this pin is pin 5, which is shown here, DS at this spot, which is connected to this terminal for DS18B20. This is a temperature sensor. Spot for the temperature sensor is in here. If I turn it around, you will see the spot. And on this module, you can see it here. This is AT24C32. This is an EEPROM, a memory where the module can read and write via this SDA and SCL pen. I did not find any explanation as to why we need this, because the module already has RAM. And here is a data sheet for DS1307 RTC clock. As you can see, it says it has 56 bytes of non-volatile SRAM. It has a calendar. It works through I2C. It has 24 hours or 12 hours clock time. Calendar is valid up to 2100 with leap year calculation. Leap year is the year that has 266 days. The typical application, we have the chip, we have a crystal oscillator at the output and with power and few components. This module can work from -40 to +85 degrees Celsius, so that's very important to know. Here from this square wave output, we can get 1 Hertz, 4 kilohertz, 8 kilohertz or 32 kilohertz. 0 or 1, you will turn it on and off. 1 and 0 is these two, or for selecting the square wave either 1 Hertz, 4, 8 and 32.768 Hertz, and a square wave will be 1, 1, 1, otherwise it will be 0. The chip is operating between 4.5 to 5 volts, the supply voltage, and the logic is 2.2 volts minimum, or VCC plus 0.3 volts. The battery current is 300 nanoampere when square wave is off, but when it is on, then the current from the battery will increase to 480 and maximum of 800 nanoampere. And here, if you have the battery voltage, a lithium battery, it says if it is 48 milliampere hour battery or greater, it will keep the backup for 10 years. And when there is no power, if the temperature is plus 25 degrees Celsius. I will provide you the data sheet in case if you want to have a look at it, but we are not concerned with this because we are not going to customize the code or library. We are just using it as a real-time clock chip. To display the calendar, including the year, month, day, hour, minute, and day of weeks. When you receive this module, most of the time the pins are not connected. It's called the pin header. First, insert the pin header on the breadboard, then put the module on top of the header and start soldering from one side to the end. Here is the wiring diagram. Ground is connected to the ground of Arduino. The VCC pin is connected to 5 volts. SDA is connected to A4 from the last second, and SCL is connected to A5. If you're using other devices, for example Uno Ethernet, SDA is A4, A5 is SCL, Arduino Mega 20 is SDA, and 21 is SCL, and the Nord and Duo, they have been all mentioned. I will provide you the link for this as well. Let me explain the code. The first thing that you need is to download this library. I will provide you the link. the wire is part of Arduino IDE. You don't need to do it, but this one you have to download it. And for this is called RTC LIB. That's from Adafruit. Let's go to Sketch, include library, manage library, or you can go to Tools, manage libraries. Wait for this to complete the bar graph. And you see RTC LIB, just type RTC LIB. Wait for a few seconds, and here it says RTC LIB by Adafruit, and here is the name of the person, Glab. So select that and install it. Install it. Wait for this to complete, and the installation is now completed. Inside this we have a class called RTC Real-time Clock DS1307, and then we create an object out of this class. This is an object or instance of this class, and this is day of week. This is a character of 7 items, each with up to 12 characters. Day of the week as text. You can see it Sunday, Monday, Tuesday, Wednesday. All of them have been saved here. Then inside the setup we check the serial, if serial exists, or is it possible, because the other Arduino might not have it. If it does not exist, while means forever it will be true and the setup will not proceed. Then we initialize the serial monitor with 9600 baud using serial.begin. This 9600 is the value that is at the lower right corner of the screen in serial monitor. And you can open serial monitor by clicking here or by clicking at the tools and serial monitor. Then we check RTC.begin. This is initializing the real-time clock. This means if it is not true, which is usually if it works, it will be true, it will print this. And while one means stay forever. And then is running. There is another function, it is checking if it is running. If it is not running, it will print this error. Do not worry about that. And inside the loop, here is the important part. We initialize, we are getting the current time, RTC.now. This is getting the current time from the clock module and is storing it in a variable called now. This is an object of date and time. Now.air, comma, decimal. This is a number, it prints 2019, and the next line we print this forward slash, and then we get the month as a decimal 3, and then we put forward slash, and after that we open a parenthesis, and then day of week. This is a number, either 0, 1, 2, 3 or 4 up to 6, and this number, if we type here 5, for example, if we type here 5, it will go inside this array and get elements number 5, and the elements is here. This is 0, 1, 2, 3, 4, 5 up to 7, and whatever day of week we have, now.day of week will return a number between 0 to 6, which is day of the week, and then we convert it to a text to print this Monday for us, and then we close it. After that we set hours. This is getting 21, which is my current time, and then we put colon, this colon here, 2 dots on top of each other, and then minute 40, and then we print second. After that ln, this new line, this goes to the next line and then print this text. The Unix time stamp, this is a timestamp that is widely used in the industry, and it has started from first month and from first day and first month of 1970, January 1st, 1970, and since then this many seconds have passed. So these are number of seconds, and then they put S for us, and then this 86,400 is number of seconds in a day. 24 hours times 60 minutes times 60 seconds is 86,400, and L refers to the data type long. Future time, for example, current time span, and we can say 7 days and 30 seconds from now. Future.year will get this calculation added to the current time. That will get us the year, month and day, the same as before, including minute, hour and second, and it prints it like that. Here's a demonstration. As you can see, this is now connected via USB, and this is the time that you are getting live. If I disconnect this scrolling of data that is coming will stop. This will not now scroll because the information is not coming. If I connect it and then close this and open it again, you will get the latest information from this. And this was the information or data that I have explained to you. Now I will remove the battery and show you that the time will be resetted. This is the bad battery. This is one terminal, and the positive is on this side, the negative is on this side, and they have been separated with insulator in here. If your screwdriver somehow connects both of these, your battery will be discharged immediately. This is now a bad battery, so I can do it, no problem. But for this battery, now it's very important that at the bottom I have to be careful. But to remove the battery, I just pull this down and the battery went out. Now the clock is running properly. Now I'm going to disconnect it and give it a few seconds. The time should be resetted. And now connecting it again. There is no battery. Let me close this and open it. As you can see, it shows that the time is year 2000, Saturday, and it says it's not running because the battery is not there. You see, RTC is not running, and also the time is January 1st, 2000, and hour, minute, and second is 000. Now let me just insert it. And even if I open it again, it will not be updated. Still, this is an old time. We have to set the time now. And here inside the setup, I'm leaving this. It says adjust. You can do adjust and put your own time, whatever time you want. The first one is, this is year, month, day, hour, minute, seconds. So this is an order from the largest unit to the smallest. Remember, month is first and day is after that. But if you want to get your system or your computer time, just put this line, which is inside day of time. There is an F, and then F will use less memory, and then this is the compiler date with 2 underscore. This is 1 underscore, another one, date, and then time. And let me uncomment this. Once you uncomment it, this is now connected. Upload the code. Now if I open this, you will see we are getting the current time from my machine here, 21:55, and it is exact time. After that, when you see that time is set, comment this again and upload it now. This time it will just upload it because the battery is here, it will hold the time. Now it shows the time, and even if I disconnect it, close this, wait, and then connect it again, and just open the serial monitor, you will see that the time has been updated 21:56. That's the time. Here is a demonstration of setting AM and PM if you want. I'm setting the time with, this is hour 20 and 8 o'clock. So I've modified the code and here I put format 12 equal true. If it is 12 hours, set it true. If you don't like 12 hours, just set this to false, and this will change. So let me set it to false and upload it. Because it's 8 p.m. we should see 20. Now the code is being uploaded. Now it shows the time without the PM. And you see here 0. If you want to add 0, that's very simple. Just check the length. If it is less than 10, print extra 0. That AM PM is being printed using this line here. If format 12 is true, then we put 12 hours now dot 12 hours. So this is getting hour in 12. Otherwise, just use hour. It will be 24-hour format. If we want to print 10, very simple here. Say if minute is less than 10, then serial dot print 0, and the same thing we can do for second and for hour as well, but we have to say second, and then let me upload it. Now you will see this one will have a 0 in front of it. Just wait. You see, now we have 0 minute and 0, so we have proper 0, 0. This is very simple task. On how to create an alarm using this and trigger, for example, a buzzer or a relay that you can turn on or off an AC or DC load or a device. And here I've connected pin 2 to one pin of this buzzer, and the other pin I've been connected to ground. This buzzer has 2 pins. So this buzzer has 2 pins. One pin is inserted in here, which all of these are connected, and the other pin, the negative, is connected in here. So the negative is connected to ground here, and the positive will go to pin 2. And when you get the buzzer also has a sign here. This is a plus, meaning this pin is a plus. Also the plus pin is longer. Let me now explain the code. This is part of the library. You have to download and include the library. The link for original video will be provided. Wire.h is for I2C communication. This is part of Arduino. You don't need to download anything. In this line, we define alarm pin 2 for our alarm. And here, this is a constant integer type array. We call it alarm. These 2 bracket means it's array, and opening and closing is here, and this comma is separating all the elements. It starts with year, month, day, so from the largest unit to the smallest. Year, month, day, hour, minute, and this is a second. If you have 8 minutes, make sure to put just 8. Do not put 0, because you will get error, and because it's a type of integer. And when the alarm is triggered, if you want to keep the alarm running for a certain time, for example, in this case, we call it wait time for 4 seconds, you can put it, and you can change this if you want. And here, inside the setup, using the pin mode, we define alarm pin, which is pin number 2, as an output. This line in my previous video have been explained that it sets the time. Watch that video. Inside the loop, this was exactly the same as before. We have printed this text alarm, and this loop will take the alarm array and will print the alarm time on the serial monitor. and this is printing. All these lines will print the actual time. Robojax.year, Robojax.month, day, hour. So this is just for comparison purpose, so we can see it on the screen. And here we use f check alarm. We pass this Robojax object to this function, which I'm going to explain next. So this will return true if alarm matches. If alarm matches the set alarm with the current time, then we use digital write alarm pin, we set it high. This is for buzzer. If you're using a relay module with a low trigger, change this to low. Low means turn on for some modules of relay. And then we also print this on the screen, and this is the delay for wait time that I mentioned above when the alarm is triggered. For some applications, when alarm is triggered, somebody wants to visit a device or something, so comment this out and then uncomment this line, while mean wait forever. So the alarm will run forever until somebody comes and press the reset button or Arduino. It's up to you, whichever you want to use. If the else means if alarm is not triggered, the pin is low, so the relay and the buzzer will be off. If it is a relay, change this to high, and then we print the new line, which I'm going to show you in demonstration, and we wait 500 milliseconds. Now this function check alarm will get this object, which we create from this instance of this class. This is an object that has time. When we pass it to this function, it comes here, the type is date and time, and now we call it time now. And here we check if time now element 0. Element 0 is year, and alarm 1, let me just remind you here. So this is 0, 1, 2, 3, 4, 5. We have 5 elements, 6 elements starting from 0, year, month, day, hour, minute, and second. So we compare and check it. 0 means year. If year is from alarm equal to the current time, time now, alarm. And the same thing, this 2 ampersand or and sign, it means this must be true and this must be true for the month and also for the day, element number 2, and hour. So year, month, day, hour, all of them must match, including the second, in order for the alarm to be triggered. If all of them are true, then we say return true, else return false. So this true or false is the value that appears here. It appears here. If it is true, this function will, this if condition will be true and this will be executed. If this is false, else will be executed, which means just turn off the buzzer. Now I'm setting that alarm for 17 minutes past 10. Let me upload it. Now it's almost 16 on my computer clock. And 9 seconds left. This is the module, and in 4 seconds you will see 1 second the buzzer will turn on, and it says stays for the wait time, which is 4 seconds. This is the wiring diagram for DS1307 module with relay to control an AC bulb. You can do also the same thing for the DC. Just remove this plug and connect it to your battery with whatever load you have instead of the bulb. This module, you can connect it either from this side or this side. Doesn't matter. We are just using 4 wires, VCC, ground, SDA, and SCL, the 2 wires that is needed to power this on, and the 2 other wires are for communication purpose. Here we have connected ground to the ground. VCC has been connected to 3.3 volts in this case, and then SDA is connected to A4 and SCL is connected to A5. For the relay that operates with 5 volts, the VN or VCC have been connected using the yellow wire to 5 volts. The ground is connected using green wire to the ground, and then this is the input where it receives the signal from Arduino. It has been connected to pin 2. And here is the wiring with the relay. I've connected the clock, instead of 5 volts, I've connected it to 3.3 volts and it will work fine. This module, I've tested it, it works with 3.3 volts, and the 5 volts have been connected to the relay. I have another video explaining how to use this relay with Arduino to turn on and off. I'm not going to explain that directly. I go with the wiring. The wire that is on the left side is VCC, have been connected to 5 volts of Arduino. The middle pin is ground, it has been connected to the ground of Arduino. The last pin is in, blue pin, it has been connected to pin 2 here in Arduino. For this demonstration, I'm going to use this AC bulb. This is a plug that will be connected to wall outlet and the light will be turned on. The middle, at this point, I've disconnected the wire, one of the wire, the live wire here, and I've twisted them and prepared them. These two will be connected to the relay. Job of relay is to turn it on by connecting these two wires, turning on the light, and disconnecting it, turning it off. So this can be a bulb or a fan or any other load, the same way the relay will connect it and disconnect it. The two wires that I've shown you for the light have been connected to this two right pin of this relay, so we can turn it on and off. Here I've set the time 22:01, that is 1 past 10, and now it's exactly 10 o'clock. Let me open the serial monitor so you can see the time. We have 30 seconds, and when the alarm goes, you will see that the green light will turn on here, and this AC bulb will also turn on, and you will see the trigger text will be displayed here. So we have now almost 10 seconds left. Four seconds, and the alarm is on. It will wait for the predetermined wait time and it will turn off, and that's it. You have to change the time again and upload it in order to trigger another event. In this video, we are going to learn how to build a digital clock using any Arduino with DS1307 real-time clock module and this HT16K33 7-segment display. A separate video fully explained this HT16K33. I'm not going to explain those. Here we are going directly jump into wiring and coding. I'm going to explain the code fully, demonstrated different features of it, because this can display seconds. You can turn it on and off, either the second can blink or it will be just a counter. Without further ado, make sure to thumb up the video and also subscribe so I get started with this. Now here I have used from 5 volts. I've connected one wire from ground, from A4 and from A5. A4 is SDA, A5 is SCL. If you're using other devices, for example Uno Ethernet, SDA is A4, A5 is SCL, Arduino Mega 20 is SDA, and 21 is SCL, and Leonardo and Duo, they have been all mentioned. I will provide you the link for this as well. And then from here I have connected one bunch of wire for the real-time clock and one bunch of wire of the same color to this display. For the display, they are exactly the same order from left to right. They are coming from left to right, so you don't have to worry. 5 volts, ground, SDA and SCL. And here for this module, this purple is 5 volts. 5 volts have been connected to VCC, to the second pin, and then ground is gray, has been connected to the first one, and then white is SDA, has been connected here to the SDA pin, and the last pin, black, is SCL, and it has been connected to the last pin, which is SCL. Now let me explain the code. Because I've used library for DS1307 from Adafruit, and I've used HT16K33 libraries. First you need to download and install this library, and then we need to install this library. For this is called RTC LIB. That's from Adafruit. Let's go to Sketch, include library, manage library, or you can go to Tools, manage libraries. Wait for this to complete the bar graph, and you see RTC LIB. Just type RTC LIB. Wait for a few seconds, and here it says RTC LIB by Adafruit, and here is the name of the person, Glab. So select that and install it. Install it. Wait for this to complete, and the installation is now completed. And then type here, and then for HT16K33 type and wait. You will see a lot of options, but the one that we are using is from Rob Tellart, and it says installed, and in your case the install button will be here, and just click and install it, and then close this. This line wire is for I2C communication. It's part of Arduino. RTC LIB is that Adafruit library for real-time clock, RTC. So we are including the library here, and from this, inside that there is a class, and we are creating an object called RTC. And this, from this class for display, we use an instance of it, and we create a object called segment, and this, and here we define the, and here we set the I2C address 0x70. Watch the introduction video to this so you will understand why we need it. And these are the settings for the clock. Here we say show clock, show second, true. If we set that to true, you will see here the time, the seconds will be displayed. And this one, 10 seconds, mean after 10 seconds this will be displayed. Whatever time you set, that is the intervals. And the blink, if you set this to 6, 3 or 5, so that number of times the second will blink. And if you set it based on not blink, based on time, then it will be for 5 seconds. It will display without blinking. And here show leading 0. If you set that, you will see this. If it is less than 10 o'clock 9, or from 1 to 9, from 0 to 9, you will see leading 0 here. But if you set this to false, you will not see it. And also show second no blink. If you don't want this to blink and just increment the number, set this to true. This is used inside the code. Show second 1, show second 2 are functions prototype that I used within the code. This is part of the clock to display it on the screen if you use it on the serial monitor. Inside the setup, we check for Leonardo, Micro, and 0. If serial is not available, it will just stay there. And this line initializes the real-time clock, RTC.begin, and this means not. If it is not true, if it is not initialized, then it will print this error for you, while 1 mean keeps it forever waiting. And again, there is another function is called is running. This is just redundant, you can remove it. And this line is printing on the serial monitor this text. This one that you see is coming from here. This 9600, if you click on Tools, Serial Monitor, or press Ctrl-Shift-M, or open, click in here, the number that you see on the right side on the lower section is 9600. If you set different number, you will not be able to see this text. Make sure to set it to 9600 so you can see the text. And this line, if you want to set the time, use it like this. RTC adjust date time. When you say date time, it takes the time and date from computer. Whatever is on your computer, it will be transferred here. And I've not updated it. But if you want to use your own time, then do not use this date and time and enter manually. This is the year, that's the month, that's the day, hour, minute and second. So uncomment that and set your own time. So this will set your own time, but you need it only once. You don't need to set it every time. You just need it only once, and once you upload it, the time will be set. And this segment.begin, that's for the display, that's for the speed of I2C communication. That is displaying, that's setting the display on. So turn this on and sets the number of digits to 4, and this sets the test when you restart it. If I restart it, you will see one test, it turns on all the segments, and this will turn it off because some of the segments will stay on, so we'd have to turn it off, 50 millisecond delay, and then turn it on. And then this sets the brightness from 1 to 15, which I'm going to demonstrate it. And from here we check if show leading 0 is set to true to display 0, then it sets the display to 4, otherwise it says set to 3, so this means otherwise. So it will set 3 digits so that 0 will disappear if you don't like it. And here we initialize the RTC, we create an object called now, which we will use to get the time. And here segment display time, this will display time, and we pass hour using this now.hour will get time for hour, and now.minute will get the minute from this object, and we'll pass it to the display. Display colon 1 mean display this colon, keep it on for 500 milliseconds, and display 0 mean turn off, and it will turn it off when the time is displayed. So that blink is coming due to these lines. And here, if we want to display the second after a few seconds, here show second no blink. If that is set, then we go to show second 2 function, otherwise we go to show second 1 function, which I'm going to explain them. And here show second 1, we get the second blink count, how many times you want to blink it, and we store it here so we can update this, not this. And then here if show second is set to true, which means to display the second, then we get the current millisecond subtracted from the remember time, which we give this millisecond to this, because this will increment continuously from the time that you start Arduino. And we check it if it is greater than, let's say if it was set to 5 seconds, then we know that okay, the time has passed, let's go for the count. And then the while will go with a count. If it was 3, so if it is greater than 0, which means 3, then we get the time, and then we increment decrement the count by subtracting 1 from it. And in this line we set the digit to 2, so the minute and hour will disappear. And then we display now second. The second will be passed here, and that's coming, and this will turn it off, keep it on, and then turn it off, and then keep it off, and then turn it on. So that's why it was blinking. And then we set the time, so we know how much time has passed. We just remember this to this variable. We do exactly the same with show second 2. The difference is this time the count is not 1 or 2 or 3, but it is 5,000 millisecond or whatever second you want. For example, 3 seconds for this to be displayed. So the counter will do the same thing, except we don't have here turn off and on. Here we have display off and display on with some delay, so it was blinking. And here we don't have it, we just wait for 50 milliseconds. It will run the loop, this while loop, until whatever time you set, past like 4 seconds, 5 seconds, it will display and disappear. And then print time will print the time on the serial monitor, which I just shown. And here, now let me demonstrate it. As you can see, the clock is running, and let's first set the time, not with the computer, but our own time. The year doesn't matter, that's month, day, and hour. Let me set it to 8 and 1, and let me upload it. So you will see the time will set from here, 8 and 1, and it started. But, and if you want to now display the leading 0 here, if you set this to false and upload it, and you will see that the leading 0, once the code is uploaded, will disappear. And now if you say show blank, no blank, right now look, after this 10 seconds it goes here and blinks 6 times because it is set to 6 times. Let me set this to 5 seconds, and here we say no blank. If you say no blank to true and upload the code, then when it shows the second, it will not blink, it will be just a counter. Now 5 seconds, I set this to 5 seconds, and now it will be just number will increment and it will come back. And here shows second. If you set it to false, this will not be displayed, and the code, when the code uploads, this is a test. So now it, after 5 seconds or whatever, it doesn't go because we set it to false, and it will never display the second. And this one, this line sets the brightness. If you set it to 15, it will be very bright. Let's see, my room is a little bright. I hope you can see the difference. Now it's very bright. Now let's set it to 1, very dim, so you can see it, the difference perhaps on camera. Now it's very dim, but I'm going to put it to 10, which is because you, in some environment you need to dim it, because otherwise it will be very annoying in dark rooms, and also save energy if you want and power it up with battery. Now let's set the time back to my computer time, whatever it is, upload it. So it will be this from my computer, whatever I have, 11:08, and you can see there is few seconds delay, 2 or 3 seconds when we upload the code. So keep that in mind. There is a delay because when the USB puts a code and compiles it, it gets the value and takes some time. A separate video with digital clock for this DS1307. Make sure to watch that video. The link is below the video in the description. Here is a wiring diagram for 4-channel relay with DS1307. From the top, for the module, ground is connected using this orange wire to the ground. VCC is connected to 3.3 volts, and then we have SDA with the brown, it is connected to A4, and SCL is connected to A5. For the push button switch, one side is connected to pin 5, the other side is connected to ground. For relay, the last pin, this is 4-channel relay, the last pin is VCC or 5 volts. It has been connected to 5 volts. The last pin on this side is ground. It is connected to this ground. The other 4 pins are connected in the same order, 10, 11, 12, and 13. For the AC bulb or load, whatever you want, for each relay, you have to connect it this way. One of the 2 wires that goes, the live, cut it and connect it to these 2 first pins. If you're using a single relay, you will be connecting it this way. The last pin is ground, connected in here. The middle pin is VCC or 5 volts. It has been connected to this point, and the S or signal pin is connected to pin 11 in case if you're using pin 11 for this. And for the AC bulb, one wire goes directly to normally open, the other wire goes to the bulb, the second wire of the bulb goes to the common or to the middle. And let me explain now the code for the unlimited alarm for RTC clock. My alarm is an array. This is multi-dimensional array that has rows and columns. 6 means 6 columns, so we have 6 elements in each row. And you can add more in here. The order is in year, month, day, hours, minute, and second. So this is 2022, 4th month, day 11. And let me explain now the code for the unlimited alarm for RTC clock. My alarm is an array. This is multi-dimensional array that has rows and columns. 6 means 6 columns, so we have 6 elements in each row. And you can add more in here. The order is in year, month, day, hours, minute, and second. So this is 2022, 4th month, day 11, 10:19 at 0. And this is the same day, 10 seconds later, 10 seconds later. So after 10 seconds, I put them for demonstration. If you want to add more, just add here like that. Put whatever you have, put them in here. So I'm not gonna do that. So this is how you do it. This is a line that is used for calculation to get the length. Whatever you add, it will be automatically added, so do not change it. And this is the name for each alarm. For example, first alarm we call it door, the second one pet food, sleep or heater, whatever. So you can name them here. The name is inside double quotation, make sure to respect that. And then for each alarm we put the pin that is controlled, pin 10, 11, 12, 13 in order. So this is for alarm 1, alarm 2, alarm 3, and alarm 4. These pins will be turned on when the alarm is triggered. And we have one pin for the reset. This pin to reset this button, so we are connecting it to pin 5. Debug true if you want to display some information on the serial monitor, this information. If we put it to true, it will be displayed. If you set it to false, it will not be displayed. And also because this will occupy your serial monitor, and this is taking a lot of resources, so turn it off if you don't need it. Show print alarm. When the alarm is triggered, it shows on this screen, so you can also turn it off. This is the relay type. If your relay type is low trigger, put low, so the relay will be turned on instead of high. The low signal will be sent to the pin. But if you type high, so the with turn on it will be high, with turn off it will be low. So make sure to set this properly. These are variables that are used for output on and off depending on the low and high type. This is the code which I've explained it in the main code, and these are variables that are used for the calculation inside for the alarm. And then this is a array that is holding the status of each alarm to check if something is triggered or not. Inside the setup, these are the same as main code. We are defining using pin mode, alarm pin, reset pin as input pull-up. So we are connecting our push button without a resistor, and we use pull-up. Otherwise we need a resistor. I have separate video if you want, search for that in my channel. And if the relay type is true, which means it is high, then output on is high and output off is low. Otherwise output on is low. You see the order is different now. That was high, it becomes low. And this is just printing the alarms on the screen. So let me show you here. If I reboot it, so yes, so it shows alarm 1, the year, month, day and hour, and the pen. The same way all alarms that you have, it will be displayed only once. And in the same time, in the same loop, we are also setting the pens as an output, and you are using the same pens using digital write as turning them off. So if you want them by default to be on, change this to output on. And this is also setting the status as off or not triggered. Inside the loop, this portion of the code will run only once. Inside the loop, we are defining all these, we are defining this object called now. We are getting the time and we call it now, and then now.year will give us the year. I'm using it separately for alarm to make it simple. So this is year, month, day and minute, hour and second. And this function is checking the alarm. And debug, if we set the debug, it will print the time, otherwise it will not print it. But I'm going to explain this, what it does. So the loop is done, and when we run check alarm, it runs I equals 0 to 1 smaller than alarm count, which I explained it at the top of the code. It goes from 0, 1, 2, 3. If you have 4 alarm, it goes up to 3 and so forth. It starts with 0 and it checks if year, month, day, hour and minute of current time is equal to the value that you set in the array at the top for your alarm. Then it goes to alarm action with the I is the alarm number, and also it sets the alarm that has been triggered. Otherwise, and also it checks to see if alarm is off or not, if trigger is not there. So that's done now. Alarm action is here. Here the I comes, that is the number. It prints the alarm which is above, but here digital write, the I comes, it goes to the array, gets the pen, for example pen 13 as on. So this will turn the pen on, and for off we do the same thing, we change the status and then we set it off. And if the debug is there also, it will be printed if the debug is true. This function is printing the alarm when it is triggered, or when you want it, whenever, at the beginning of the code and also later on when alarm is triggered. So that's a full explanation of the code. And here is now the demonstration. I have set the time for 0, 10 seconds, 20 seconds and 30 seconds. As you can see, the first one is turned on, and now after 10 seconds, 3, 4, 5, 6, 7, 8 and then 9. After 10, this one will turn on. At 20 seconds, this will turn on. And as you can see, at 30 seconds, this will turn on. And now to reset it, I'm just pressing this button. All of them will be resetted. And now I'm going to show you to build this LCD clock with the same module. We are just using the 4 wires of this module, the same as before with the same module. And on the screen I've arranged it such that we will see the date, the day, month and year, and then this will be the time. This is the actual time and day of the week. Of course, on the code you can remove and move them up and down. I'm going to explain the code fully so you will understand how this is being displayed. Here is the wiring diagram for DS1307 real-time clock with LCD. This portion is exactly the same. Ground is connected to ground, VCC is connected to 3.3 volts. Because we are using LCD, this is connected to 3.3 volts. SDA is connected to A4, SCL is connected to A5. For the LCD, ground is connected to this ground. The next pin is VCC, it has been connected to 5 volts. And then we have SDA from the last second on this row, and SCL is connected to the last pin on the row. Now let's install this library. I will provide you the zip file, download it and save it, and after that click on Sketch, include library, add the zip library, and then point it to where you have saved it. For example, if this was inside download, go and select that zip and click open. Once you are done, then this is ready. Now let me explain the code. This is the same as regular clock that I just mentioned, days of the week, name of the month. We are not changing it. This is the line that is including the library, and from this class we create an object called LCD, and then we pass 3 parameters. This is the address for the LCD. This address, each device has an address, so you have to find out the address for that. I will provide you the I2C scanner. This is I2C scanner code. Don't worry what it does. I'm just uploading it and uploading it to Arduino without anything, and then just opening this. Wait and see. It says it found the address. Make sure that your serial monitor is set at this bottom 9600, and you will see. So the address is 0x3f. That's the address. We are closing this, we don't need it. So that 0x3f is the address that I have written here so I don't forget. And each device will be different. For this is, for example, 0x27 for this 4 line. And then 16 means, and this 16 means 16 characters, and this 2 means 2 line. This is 1 line, 2 line. If you're using 4 line, put it 4, and if this is 20, just put 20. So after that, inside the setup, this was the same as before. I'm not going to explain it. Only the LCD.begin initializes the LCD. This is turning the backlight on. If you want to turn it off, just comment this like that and the backlight will be turned off. I'm leaving it on. This is just printing the text Robojax. And this line, it says LCD set cursor. It goes to character 0, line 1. So this was automatically on line 0. This goes to the next line and prints LCD.print, and inside the double quotation you put whatever text you want. Now let me reset this to show you. So you will see here Robojax and then the text. After that, inside the loop, we first using RTC.now. This is getting the current time, and we create an object called Robojax. So the time is being stored here as a Robojax of type date time. This is a type of data, and then LCD clears the screen from the previous value, and we set the cursor using 0, 0. So in this case it goes to line 0 and then character 0. That's character 0, and we get robojax.day, that object, and then .day will get the day. So this is printing the day, as you can see. Let me reboot this because I was touching it and the wires were disconnecting. So day, and then we have a space and then month name, Robojax. It goes to this array that we have at the top of the code, gets the month, subtracts 1 because the month starts from 0, and then this will print the month name. Whatever you put, this name is coming from this text, so change. After that, inside the loop, we first using RTC.now, this is getting the current time, and we create an object called Robojax. So the time is being stored here as a Robojax of type date time. This is a type of data, and then LCD clears the screen from the previous value, and we set the cursor using 0, 0. So in this case it goes to line 0 and then character 0, that's character 0, and we get robojax.day, that object, and then .day will get the day. So this is printing the day, as you can see. Let me reboot this because I was touching it and the wires were disconnecting. So day, and then we have a space and then month name, Robojax. It goes to this array that we have at the top of the code, gets the month, subtracts 1 because the month starts from 0, and then this will print the month name. Whatever you put, this name is coming from this text, so change. The name of the month is coming from here, and then we have a space. After that we print year, space, and then we have year here. I've created this space so you know now LCD.cursor, it goes to character 0, line 1, which means it goes, this is line 0, line 1. Then we print robojax.hour, that's hour, we set colon, then minute, colon, and then we put second and space, and we check if the second is less than 10, it's single digit, so we print extra 0, then we print the second and space, and then we print day of the week, like Thursday, Wednesday, Thursday, Friday, or whatever, which is at the top of the code, and we have 300 milliseconds, and here hour, colon, minute, colon, second, and then day of the week, and that's it. So this was a full explanation of the code. Now I've commented this out, so day of the week is not displayed, and here that has disappeared, and hour, minute, second, perhaps you need it. If you don't want the whole calendar, comment this all out and then change this to 0, 0 like that, and just comment this, and let's upload the code. Just wait, this time will move up. So now this is a clock. Now you see there is 1 0 for hour. If you want to show 2 0, we will do it like this. You see this second, the same way for hour we do it like this, and here we say if Robojax hour is less than 10, add 0 and then print hour. Let me upload the code. Now wait for this. The code is uploaded. Now you will see it like that. If you want to, let's say if you want to move this whole calendar at the bottom, We can do so by right click and comment this. So we go character 0 line 1, we set first the cursor and then print this. Now we will see, now it shows here. So this way again the day of the week is now commented out. Let me uncomment that and upload the code, so we can have here day of the week like Wednesday, Thursday or Friday. Like this. Now let me replace it with this 4-line 20 character. Now this will not work. We have to set the address 0x27, which already I know. Here 27 uploaded, and this one, even if I don't set it 16, we can set it at 4 character. I'm going to show you. So this is just changing, after changing the address, this is how we see. Okay, but you can move the mandate down if you want, and you can make it fancy by just moving the lines. And here if you want to display AM or PM, here I've added now this format 12 equal true. If you want 12 hours AM PM, put this true, otherwise set this to false, FALSE, like this, so it will be 24 hours. And in the code I've changed this, so here to get the hour in 12 hours you put the object name dot 12 hour, otherwise just put hour. So this will get a 24-hour format and this will get 12-hour format for you. Let's set this to false. And the code is being uploaded. Once it is uploaded, then right now it's at the process of uploading. This will be eliminated and you will see it like this: 20 hours and 5 minutes and 21 seconds. And if you plan to use this 2004, which has 20 characters and 4 lines, simply swap it with the larger display, but make sure to set the address in the code. And as you can see, it's working perfectly without any change in the code except the address. Now I'm going to show you the unlimited alarm with the LCD, where this will have an alarm at, for example, 44 or 45, whatever time you set, and alarm will trigger and you can turn it off using this push button. And here is the code. The code is exactly the same as before, but my alarm here we set year, month, day, hour, minute and second. So these are the values. You can set whatever value you want. If you want more alarm, just add one more line like this, so you can have more. Simple as that. And this line is counting the number of alarms that you have. Do not change it. And this is the name for each alarm. We have 4 alarms. Inside a double quotation, put your text. Your text cannot contain double quotation, so you have to use escape character if you want to use it. And these are the pins that is connected alarm pin. So I have 4 alarms and 4 pins must be presented here. So this pin 10 when the alarm triggers, this pin will go high, so you can control something, relay or whatever you want. This is a pin that is connected to alarm reset pin, pin 5, and show alarm pin. I've created one extra pin to show the alarms, and this is now connected to pin 6. If I connect it and press this push button, it will show alarm 1, the name is work, and this is the time and date, and alarm 2, it shows something like that, which I'm going to demonstrate it. And here is the code. The code is exactly the same as before, but my alarm here, we set year, month, day, hour, minute and second. So these are the values. You can set whatever value you want. If you want more alarm, just add one more line like this, so you can have more. Simple as that. And this line is counting the number of alarms that you have. Do not change it. And this is the name for each alarm. We have 4 alarms. Inside a double quotation, put your text. Your text cannot contain double quotation, so you have to use escape character if you want to use it. And these are the pins that is connected alarm pin. So I have 4 alarms and 4 pins must be presented here. So this pin 10, when the alarm triggers, this pin will go high, so you can control something, relay or whatever you want. This is a pin that is connected to alarm reset pin, pin 5, and show alarm pin. I've created one extra pin to show the alarms, and this is now connected to pin 6. If I connect it and press this push button, it will show alarm 1, the name is work, and this is the time and date, and alarm 2, it shows something like that, which I'm going to demonstrate it. And this is part of the main code. Do not change it. Alarm status is an array that is holding the status of alarm. The rest are exactly the same character number, 20 or 16 if you're using 16 character, and 2 line, and alarm line where you want to show it. If it is line 2, you will show it in line 2, otherwise change it to line 3 if you're using 4 line display. This is the same as before. We are setting the address, character number 16 is coming here, and line number, how many lines you have. So this is the same as the basic alarm that we have. Portion is in here. This is the line that does it. So we say check alarm. This is a function which I'm going to explain, and after that it clears line 0. So clear line is a function that is added here. The rest is exactly the same. So let me explain check alarm. In check alarm, we check the count number. So this I is from 0 to 1, smaller the count, and the loop will continue. So we get this value that you have in your my alarm array and checks it with year and with month, day, hour, minute and second, and if everything matches, then alarm action function with I that we have will go and will be triggered, and also alarm status will set to true in this array with this index. And otherwise we have also here alarm off, check to see what the alarm should be turned off. So this is turning off the alarm. It turns it off automatically, and this is printing the alarm on the screen. When we run the print alarm, we will see it when we go to alarm action. First let me explain that one. Alarm action comes here, it says print alarm, which is the above line, and this line it says digital write alarm high, and this line should be below this, so the action is taking first and then it prints it on the screen. So this goes to print alarm, in this section, this is printing the alarm on the screen like this. Print alarm triggered. So this is printing when alarm is triggered. This line is when you press the push button, print alarm. So this will print it. Now alarm action, print alarm triggered. So this is printing it on the screen. And alarm off checks it to see if this pin is equal low, and it will turn it off when you press a push button with alarm reset pin. So it changes the state, it sends the pin to low, and also on the serial monitor it prints it. Perhaps you don't need it, and also we clear the line 1, which is the alarm pin. And this function is very important. I've written it because many people have problem with clearing specific line. So this is just clearing the line, and put here the number, whatever you want, and call it, and it will clear the line for you. Here's the wiring diagram for DS1307 with LCD and 4-channel relay. First, I've placed this breadboard from 5 volts. We have connected it to this line, so this is all 5 volts. And from ground, I've connected it to this line, and this is now all ground. Ground is connected to ground of breadboard. VCC is connected to 3.3 volts. SDA is connected with a brown to A4. SCL is connected to A5. Push button is the same as before. One side is connected to pin 5, the other side is connected to this ground or to this ground, doesn't matter. Now, for the relay module, VCC is connected to the 5 volts of breadboard. Ground is connected directly to this point, ground, and 4 pins are connected in the same order to pin 10, 11, 12, and 13. The AC, one wire, the live wire, preferably the live wire goes to first pin. From the second pin it is connected to one wire of the bulb, and the second wire also goes to the bulb, so the relay will turn it on and off. For the LCD, this ground pin is connected to this ground here. VCC is connected to 5 volts. SDA is connected to the last second, and SCL is connected to the last pin on this row. And here is a demonstration at 10 hours and 39 minutes and 40 seconds. We will have alarm. It will be triggered. The day is today. So let me show you. Now at 40, this will 10, 39 and 40. So now it's 30. So this text will change. First we will see the alarm name, and then inside the bracket we will see the alarm work. So it's triggered now, and it shows the time. So it is now remembering. You see this does not fit. We cannot see it, but if you want to reset it, when you reset it here, it just disappears. And the same way, if I connect this larger and change this to 20 character and 4 line, that doesn't matter actually. I'm not changing it, just 27. And the time now, so it's 11:41. Now let's put it at 41 and one of the alarm at 4140. So 41 and 40, let's upload it. So 10 hours and 41 minutes and 40 seconds. I hope it is uploaded quick so you can see it. Uploaded, yes. So now alarm is triggered and you can see the full length on the screen. And if you want to reset it, just press this. So the reason now for this that it has not been cleared is this, because I did not set the length properly. So make sure to set this if you're using 20 character, then this would clear it. Thank you for watching the tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. In this lecture, we are going to use the DS1307 real-time clock module, the built-in alarm of this, which are 3 alarms, and we will trigger a load or something so you know how to use it. Then we are going to build a clock using LCD screen so we can display the calendar, date, time, month, year, and the full time on the screen. And after that, I'm going to demonstrate and show you how to have unlimited alarm, because this has very limited alarm that you can set, but I'm going to show you how to have unlimited alarm when the code will be provided. This unlimited alarm also will have a switch where you can press it and will turn off the alarm when it is triggered. Then I'm going to use the HT16K33 4-digit 7-segment LED display so we can build a